Hey, welcome back to Math with Patrick. Today is September 28th, and we are solving problem 271 from the Daily Epsilon calendar. And the answer today should be 28 because it matches today's date. So we need to find the sum of the proper divisors of 28. A divisor is just a number that divides another for us to get a whole number result. So if we were thinking of 28, thinking of some divisors, I could divide it by, say, 4, and that would give us 7. So 4 is a divisor, and then flopping those numbers around, 7 is also a divisor as well, because we would get 4. Another word for divisor is just factor, because if we multiply 7 and 4, we get 28. So it's kind of the same idea. You can call them factors or divisors depending on just like how you're thinking about it. A proper divisor is still a divisor. It's just not the number itself. Like, of course, 28 is a divisor of itself because we do get a whole number result. It's just that a proper divisor is considered to be one that is smaller than your actual number. So we can just write some factor pairs, and I'm calling them factor pairs right now because I'm thinking of them in like a multiplying way instead of a dividing way, but they're the same number. So if we think of factor pairs, we can generate some divisors of 28. 1 times 28, 2 times 14 is still 28, and then 4 times 7 is still 28, and that's it, really, because I'm like kind of counting up this way and then also up that way. And so I know that like 3 isn't a divisor because the nearest multiples of 3 are like 27 and 30, not 28. 5 doesn't work because the nearest multiples of 5 are 25 and 30. And then 6 doesn't work because the nearest multiples are going to be also 30, maybe like 24 or 36. So these are all of the factors or all of the divisors we're ever going to find for the number 28. And since they are proper divisors for this problem, we need to get rid of the 28 itself. So now we just need to find the sum of all these proper divisors. Let's just add them low to high. 1, 2, 4, 7, 14. These make a 3. And then these make a 7. These make a 14. And then finally 14 plus 14 gets us back to 28. So kind of interesting that the sum of the proper divisors of 28 is also 28. This makes it a perfect number. That's just what it's called in math when you do this process and you get the same number that you started with. The smaller perfect number is 6, because like we could do like 1 times 6 or 2 times 3. And then when we get rid of the number itself and only sum up the proper divisors, we get 6 again. And this isn't the case for all numbers. Actually, it's very, very rare that you would get a perfect number. Like if I tried it with 10, for example, that's 1 times 10 or 2 times 5. And then crossing off the 10, 1 plus 2 plus 5 only gets me to 8, not 10 itself. So it's kind of a special property of 6 and 28 and some other numbers out there. And if you ever find an odd perfect number, let me know. Anyways, that's the problem for today. I hope you enjoyed, and I'll see you tomorrow.